Define structured data objects known as structured variables or simply structures in RBAP by combining values that belong together logically to one data object. Structures can be nested. This means that components can be made up of more structures or even internal tables. Define structure variables in the program in the same way as elementary data objects with the data statement. When you set the types, you can refer to the following: a structure in the RBAP dictionary that is global structure type, a structure type that you declare locally in the program.
The figure shows the definition of a structured variable using a locally declared structured type. Use the type statement to define local structured types. Here, the components are enclosed as shown. Types: begin of structure name, end of structure name. Assign a type to each component by using the type addition. For more details, refer to the keyword documentation for the types statement. Define the data object in the usual way. If necessary, you can also define a structured data object directly. To do so, all you have to do is replace the leading keyword types with data. Data: begin of structure name, end of structure name.
Components of a structure are always addressed using a hyphen, structure name hyphen component name.
The statement move corresponding copies the content of the source structure to the target structure, one component at a time. Here, only those components that are available under the same name in both the source structure and the target structure are considered. All other components of the structures remain unchanged. The individual value assignments can each be executed using move. Trace the field content of a structure in the RBAP debugger by entering the structure name in the variable 1 area or copying it from the source code by double-clicking on it. Display the component of the structure by double-clicking on the structure name in the variable area. In addition, you can configure a display area for structure display on one of the desktops. To display a structure variable in the classic RBAP debugger, use the double-click method. By double-clicking on the structure in the source code, you copy the structure to the field view. Double-clicking on the field view takes you to the structure display, where you can read the name, content, and type of the individual components. Typical uses of an internal table. It retains data from database tables or sequential files for future processing. It formats data for screen or printer output, for example, sort. It formats data for using other services, for example, for method, function module, or subroutine calls.
Properties of an internal table. Line type. The line type describes the structure of table rows. You usually specify a structure type for that, but any data types are possible. Primary key. The primary key of an internal table consists of ordered key fields. The system uses the sequence of key fields, among other things, for sorting according to keys. Depending on the access type, the primary key can be defined as unique or non-unique. Uniqueness means that a particular combination of key fields can only appear once within the table. Table kind. Table kinds are of three types: standard, sorted, and hashed. Depending on the access type used, you should use the appropriate table kind for the definition to enable high-performance access.
The figure illustrates the selection of the appropriate table type. You can access a table entry in the following ways. Index access. Specify the corresponding row number. Key access. Enter a key value. Depending on the access type, choose the most suitable kinds of table to enable high-performance access. Table kinds. Standard tables. The system maintains the row numbering or index internally. Both index and key accesses are possible. Choose this table kind if you mostly use the index to access the internal table. Sorted tables. The system sorts data records in the ascending order of keys. The system maintains the index internally. Both index and key accesses are possible. Choose this table kind if you normally access the internal table with the key or would like the table to be automatically sorted by key. Hashed tables. The system manages data records for fast key access using the hashing procedure. A unique key is required here. With hashed tables, only key accesses are possible. Choose this table kind if the internal table is very large and you want to access it by key only.
Internal tables have table types that can be defined globally in the RBAP dictionary or locally within a program. The figure illustrates a table type declared in the RBAP dictionary as well as the program internal definition of a table variable with reference to the table type. For detailed information about the declaration of global table types in the RBAP dictionary, refer to the online documentation. You can access this using information in the display or in the maintenance section of the table type. The figure illustrates a table type declared locally in the program as well as the internal definition of a table variable in the program with reference to the locally declared table type. When you list key fields in the table type, note that the sequence matters for certain types of processing, such as sort by key. For detailed information about declaring local table types, refer to the keyword documentation for the types statement.
In the previous definitions of internal tables, RBAP dictionary objects such as a table type, for example, BC 400_T_flights, or a structure type, for example, BC 400_S_flight, were used. The figure illustrates an independent table definition. The independent table enables you to implement internal tables with any kind of structure without referring to existing dictionary types.
The figure illustrates an overview of possible definitions of internal tables.
For processing single records of an internal table, a structure variable that has the same type as the line type of the internal table is required. This structure variable is known as the work area. The figure illustrates the processing of an internal table in the corresponding work area. Use internal tables as follows. Append. This appends the content of a structure to an internal table, and this operation can only be used with standard tables. Insert. This inserts the content of a structure into an internal table. Read table. This copies the content of a table row to a structure. Modify table. This overrides an internal table row with the content of a structure. Delete. This deletes a row of an internal table. Collect. This accumulates the content of a structure in a row of an internal table that has the same key, and in doing so, only non-key fields are added. Hence, this statement can only be used for tables whose non-key fields are all numeric. For detailed information about the ABAP statements described, refer to the relevant keyword documentation.
Process sets of records using the following. Loop at, end loop. This places the rows of an internal table into the structure specified in the into clause one by one. Within the loop, the current content of the structure can be output, or you can change and write the current content back to the table. Delete. This deletes all rows of the internal table that satisfy the logical condition. Insert lines of. This copies the content of several rows of an internal table to another internal table. Append lines of. This appends the content of several rows of an internal table to another standard table. For detailed information about the ABAP statements described here, refer to the relevant keyword documentation. You will now be introduced to some actual examples of syntax for the most common statements.
Insert a row into an internal table by writing the data for the required record into the prepared work area and then inserting it into the internal table with an insert statement. With standard tables, this content is appended in sorted tables. The row is inserted in the right place with reference to key fields, and in hash tables, it is inserted according to a hash algorithm.
Read and edit the content of an internal table row by row using a loop. Within a search run, the SY-TABX system field contains the row number of the current table entry. In the example, the system processes all rows of the internal table consecutively and produces the output using the write statement. If you want to change the content of the current table row within a loop pass, change the copy of the row in the work area, and then write it back to the current table row using the modify statement. The syntax for this is modify I-tab from WA.
In the loop statement, restrict access to specific rows using the from to addition. In the example, the system only processes the first 5 rows of the internal table consecutively. Use the read table statement to read a single record. Use the index addition to specify the row number of the required record. In the syntax examples, outputting an internal table row by row and reading by index, an index is used. This is only possible with index tables such as standard and sorted. While in the loop, restrict access to specific rows using the where addition. In the example, the system only processes those internal table rows in which the car ID field has the value LH. You can use the read table syntax in the figure to read a specific row of the internal table. In this case, you have to specify the complete key value of the entry to be read after the with table key addition. The return code SY sub RC is only set to 0 if a corresponding row was found in the internal table. With the with table key addition, you have to supply all key fields with data. To limit the fields, you must use the with key addition. Standard and hash tables can be sorted in ascending or descending order by the table key or columns by using the sort statement. If neither ascending nor descending is specified as the sorting order for a sort field, the field is sorted in ascending order by default. Language-specific sort rules can even be taken into account if necessary. Use the optional as text addition to implement lexicographical sorting. In a German-speaking environment, for example, this means that A comes before B and not behind Z, as would be the case with non-lexicographical sorting. When using the optional stable addition, the relative order of data records that have identical sort keys will remain intact during sorting. For more details, refer to the keyword documentation for the sort statement.
You can use the following statements for deleting the table content. Refresh. This statement deletes the entire content of the internal table. A part of the previously used memory remains available for future insertions. Clear. This statement has the same effect as refresh for internal tables without a header line, all those that have been previously defined in the course. This statement initializes the header line for internal tables with a header line. Free. This statement deletes the entire content of the internal table and releases the previously used memory. Use the free statement for internal tables that have already been evaluated and are no longer required in the further course of the program to make the no longer required memory available again.
In the ABAP debugger, trace the content of an internal table by entering the table name in the variable 1 area and then branching to the table display by choosing the table name value in the variable column. Alternatively, choose the Table tab page and specify the table name in the internal table field. Press Enter for displaying the table content. In addition, configure an area for displaying an internal table on one of the desktops. To display an internal table in the classic ABAP debugger, provide a key with the label Table, as with the new ABAP debugger. However, you can also navigate to this display by choosing the table name value.
Using the with header line addition within the definition of an internal table, you have the option of creating a table with a header line. When this is done, a work area, that is, header row that suits the table, is created automatically so that an additional definition of the same is not necessary is created. This also simplifies the syntax of table commands, as the system always refers to the automatically generated work area, which no longer has to be specified explicitly. Internal tables with header lines are mentioned here because some older programs still use them and you have to work with such programs from time to time. It is for this purpose that further particularities of the header line are listed.